morning. This is our mini project on the topic predictive healthcare for underserved communities. So, in India and globally, actually, people living in poverty in rural areas or without insurance get sick more. And we wanted to understand exactly why and build a system that can predict who is at risk before they get diagnosed. So this was a problem statement, and in this we identify individuals at high risk for chronic diseases and underserved populations, uncover social determinants of health, provide forecasting models, and deliver actionable insights for public health interventions. So the question we asked was, can a machine learning model trained on both medical data and social factors like income, food access, and distance to a clinic predict diabetes and hypertension better, and tell us which of those social factors matter most? So for that, we had first of all we installed all the libraries and imported the libraries. After that, our data collection and our data loading took place. So we built a data set of 2,000 synthetic patients modeled after real CDC health service, and each patient had 23 features across three groups: their social situation, their clinical measurements like glucose and HbA1c, and their lifestyle habits. So we can see that here there are different columns such as age, community types, insurance status, food desert, etc. So these were the different. Here we did web scraping, and from that we collected this data set, and it had other segments as well. So from all this data sets which we collected, we found out that one of the most striking findings from our EDA was patients below the poverty line had diabetes rate of 42% compared to just 19%, and for those above it. That is like there is a 23% point gap caused purely by income. And uninsured patients had 47% diabetes rate. So it was all done by our EDA model. So we can see that 50.1% diabetes was prevalence and hypertension was 41.9%. Then there was diabetes rate by insurance, diabetes rate by their income level, then BMI versus glucose. So this was a scatter plot, and it indicated that people who had BMI above 50 and glucose above 125 had more chances of getting diabetes. So, so we could also see that below poverty had a higher chances of getting diabetes as compared to those who had higher income. So after that, we did some SDOH analysis as well. So in this, we saw clinical feature correlations, we saw healthcare access scores, then the physical activity versus diabetes rate, then food desert impact. Food desert means that if there is a shortage of food there. Then we saw HbA1c by education level and distance to clinic versus healthcare. So after that, we did some statistical significant tests such as chi-square tests, which was between categorical versus diabetes, and Mind-YTU test, which was for numerical versus diabetes. So categorical features were community types, income level, insurance status, etc., and numeric types were age, BMI, glucose, etc. So the basically the data preprocessing pipeline we followed was first we removed duplicates, then we clipped extreme outliers such as like blood pressure reading of 300 were through of the model because some discrepancies are there. So we also filled in missing values for cholesterol and HbA1c. So instead of using a single global average, we've filled missing values with average for that patient's community type because rural patients have different typical values than urban patients. So it preserved the social signal and data. We also did feature engineering. So in feature engineering, we created five new engineered features using including diabetes, risk index that combined BMI, glucose, HbA1c, and age into one score. and health barriers score that combined clinic distance, food desert status, and access score. So it gave our model richer signals to learn from. So then coming to the learning models which we used. So we trained and compared 8 different machine learning classifiers on same data, ranging from simple logistic regression to power and symbol models like XGBoost. Then from this, we saw that XGBoost came out at the top with an AUC ROC score of 9364. So we did that, we implemented hyperparameter tuning on that. So after that, our score was increased further. So here we can see the performance matrix by models. We can see that the best performing model according to AUC ROC was our XGBoost. So we hyper tuned that using randomized grid series. And after that, our RUC, AUC ROC went up to 0.9516 and its F1 score increased as well. After that, we did SHAP feature importance analysis as well. So to understand exactly why the model made each prediction, this is what separates black box model from one that a model doctor can actually touch. So here we saw that the most common features were HbA1c, glucose, BMI, diabetes, risk index, etc. And we created a summary plot as well. The next part was time series forecasting. So beyond predicting individual patterns, we also looked into where disease rates are heading as a population. So we built a 10-year timeline, a 10-year monthly timeline from 2015 to 2025 and use Sarima model to focus into 2025. Here we can see that observed diabetes rate spiked between 2020 to 2021 due to COVID prevalence. And during this, due to vaccines and other diseases as well, the diabetes rate increased. And that's why our trend component has a peak between 2020 and 2021. The seasonal component was stagnant throughout, and we can see that residual component also uh, saw a spike between 2020 and 2021. So our Serima model actually achieved a R square of 0.81 on the test, which means that it explains 87% of variance and disease rates. We also created an interactive dashboard. So, in interactive dashboard, we had different features such as disease prevalence by community. So it was interactive. We can zoom into a particular subsection of it. Then it was for risk factor distribution, focused diabetes trend, income versus disease, model performance, SDOH risk score, feature importance. So as we saw, HbA1c, glucose, BMI, diabetes risk index. We also saw age risk heat maps, such as that if they were an obese 2 plus and the age was between 60 to 70, so there was high chance of them getting diabetes. So after that, yeah. So after that, I would like to summarize that our XGBoost model achieved an AUC ROC of 0.863 finally. And SHAP analysis confirms that social factors such as income, food access, clinic distance are among top 10 predictors of diabetes. And our forecast also showed diabetes rate will hit about 14% if will reach 14% if no action is taken. So this project proved that where we live and how much money we have affect our health as much as our genetics. And with the data science, we could measure the impact on it and we could predict what would happen if we do not take measures on it. Thank you.